Up next on my tiny bench is this wonderful Magnavox CDB560 from 1987. Magnavox made some really nice machines back in the 80s. I say Magnavox, technically it was a Philips-based machine with the swing arm, which I'm sure we'll see momentarily. 560 sits right in the middle. 460 is the unit below it. Difference between the 460 and the 560 largely is that the 560 is remote capable and the 460 was not. And then the 650 is the model that's above this, and there are a few differences. It had a functionality it called FTS, which would allow you to program, for lack of a better word, a sequence of tracks for a given disc. And then when you played that disc next time, it would remember how you had programmed that particular disc, the sequencing. It also featured a fold out track select. So if you wanted to go directly to track 5, you could just fold the little mechanism out, the keyboard out, and push 5 and then push play, and it would start you at track 5. On the 560, you have to either use the remote or just step forward to track 5. In the 460, you would just step forward to track 5. This unit comes to us today with the complaint of no power. I've not tried that yet, but the next step will be to see if we can duplicate the symptom as described. Since it's a power issue, I will run it through a dim bulb just in case we got a short in there. Don't want anything disastrous to happen. Usually a CD player, I wouldn't worry about running it through a dim bulb like I would with a receiver or integrated amp or regular amp. But in this instance, I'm going to do that. And I will do that on the next little clip. More then. Back on my tiny bench with this Magnavox CDB560. And as I mentioned before, the complaint is no power. I guess you can't quite see the bulb. Let me move this camera up a little bit. Excuse that jiggly. And let me see if we can just turn this light off for 1 second. All right. If we turn the power on, what's likely to happen? A few times I've seen these units where the complaint was no power, but actually what the true symptom was no front panel control or lighting. There was power, but problem in the front panel, making it look like no power. Let's see what happens when we plug it in. Do we have a disastrous short? I think you can see in the camera that dim bulb tester comes on, glowing faintly. That would suggest we probably don't have a short, or it would be much, much brighter. And also that we've probably got some current flow. So could very well be another front panel problem, another front panel issue. I'll pop the cover off and see if anything's obvious. And I'll be back with that in a moment. More then. As promised, we've pulled the top off this Magnavox CDB560 and got a little bit of dirt, but what would you expect? I just checked the fuse and it was fine, and there is nothing that's obviously blown up here. I'm theorizing that we have probably one of the rails is down. The way this works, there are 4 regulators, and they produce DC voltage from the AC off of these transformer secondary windings, and they then send those voltages through this board and also to the mech unit through this connector here. And what's sent through here is, as I recall, plus 12, plus 5, minus 6, and minus 12. So I think what I'm going to do next, since there's nothing obvious here and we've done a pretty thorough visual inspection, I think I will pop this, apply a little power, and see what voltages I'm getting on those 5 pins from the stucco connector. I'll be back with that momentarily. We're back inside the guts of this Magnavox CDB560, and as you can see, I've pulled this connector from the board, getting ready to turn it on. What I found, or what I years ago found, is that these connectors are roughly the same size as our modern DuPont style or breadboard style pins and connectors. So that's what I've got connected into the voltmeter here. I've got ground, and I believe I'm on the +5 rail. So let's give some power and see if we've got voltage there. Oh, looks like we've got over 11 volts, so I think I might have been wrong. That might be the 12-volt rail. Let's just see what's next. And again, this is plastic, so coated in plastic, insulated. There's 5. We get a better light. So we've got 2 out of our 4 voltages anyway. Minus 12, and then minus 6. Minus 6, yeah. So even though the symptom came in as no power, obviously we've got power. And the machine is producing the 4 primary voltages that it uses throughout. So what I want to do now is I want to turn the power off, put it back in place, and just grab a couple measurements on these blue axial capacitors. Let me get set up for that, and I will be right back. All right, we're back with the Magnavox CDB560. Got my peak ESR capacitance meter. On the first cap that I'm checking, shows as in-circuit leaky. I suspect it's more leaky than because it's in circuit, but it is showing 3.7 ohms ESR and in-circuit leaky as the capacitance reading. Probably have to pull these to get better readings, but I just want to get a preliminary idea of what's going on here. This one, in-circuit leaky. ESR is not that high, less than 1. Let's try this one. .2 ESR, in-circuit leaky. 2.2 in-circuit leaky. This one is reading 4.05 microfarads, 18.9 ohms ESR. Just verify that's which one I think it is. That's a 2.2 microfarad, so increased to almost twice what it started as. And then this must be the 1 microfarad. Let's see what she wants to read. .5 and 13.8 ESR, ohms ESR. So be wise to just replace all of these blue axial caps. I know a lot of people want to replace the power supply capacitors as well. I generally measure them, and if they're spot on with a super low ESR, which frequently they are, I leave them alone. If they've drifted at all, then I just swap them out. Also, there's a lot of talk on the forums and on internet generally about replacing these axial caps with more traditional radial caps, but I usually just replace them with this style, Vichet. Stays axial, so it fits nice. You don't have to worry about then shielding the leads, because as you can probably see, got quite a gap from where one lead would go in and where the other would. And this copper plating is a ground plane. So I get a little nervous about something happening to the insulation that you would have to put on the legs of radial caps. And of course, you know, if you're working on one, do whatever you're comfortable with, whatever you think is right. All I'm saying is the way I like to do it myself. Just quickly, back here, we've got audio out, digital out. These op amps produce that line. These two caps are the output caps. So a lot of people, especially those mid-90s or so, when they found these to be really good machines to tweak for audiophile purposes, they would replace these sometimes with just audiophile caps, other times with film caps. A lot of people removed these op amps, put them on sockets, and just swapped out, did some op amp rolling. That's certainly an option too, but my primary goal today or during this session is to just see what's wrong, see if we can get it repaired, see if we can get it fixed. I think what I'm going to do now is I'm going to take a look at the front panel boards. There's a control and a display board there, and sometimes if those caps are bad, it'll control, or excuse me, it'll affect the control microprocessor and make it look like there's no power because the front panel is just non-responsive. I'll be back with that momentarily. So we've removed the front panel entirely off of the unit, and I like to put painter's tape on the face just to help reduce scratches. It's too easy to kind of lose sight of the fact that you'll be putting pressure on this, pushing down on it, and just too easy to scratch that 40, 50-year-old plastic. So we've got two capacitors exposed right here of that blue axial type. Let's see how they measure. I think this one is a 47, and in-circuit leaky, and you see the ESR is 6 ohms, so that's definitely bad. I think the other one is a 2.2, if I'm remembering correctly. And again, 15 ohms. So those both got to go. Let's pull it apart, take a look at the board below it. So the way these work, sort of pinch on and compressed. So you sort of have to pinch two sides and then pinch the third leg, and then they'll kind of come off, separate. I like to do the two on this side first, and then do this one, because then these wires can act a little bit like a hinge when they're needed to. This is a sweet little green LED that lights the top of the CD when it's playing. The green LED light will then reflect off of the spinning disc, which, you know, looks kind of cool. So now we've got 1, 2, 3, 4, 5, 6, 7 screws to undo. I'll have to retrieve that one in a moment. And let's just see. Lift straight up, pull it out of the way, and I want to be careful here because these buttons will just come right off. So we'll leave it like this. And I'm not quite sure where that one runaway went. Oh, I think I see him in there. This calls for tweezers. Come on and tweeze me. All right. So the big reveal here shows these two capacitors. Get some measurements. That one's reading, again, 6 ohms ESR. In-circuit leaky. The other one's reading almost 6 ohms ESR, in-circuit leaky. Top item, 47 mics. Those are both 47 mics. And for you younger folks that aren't used to reading this style, polarity-wise, of capacitor, the line is the negative side, the dent is the positive side. And I usually try and take a lot of pictures. Just last thing you want to do is get the wrong polarity, right? I heard that can lead to bad things. Another thing I'll do is I'll just put a tiny dot on the negative side as I'm replacing them, then it'll be easy to know. Line, negative, line, negative, line, negative, line, negative. Okay, I will swap those out and be right back. All right, before we do any testing of the unit, after I now have those new capacitors in, I want to show the old ones. And frankly, I'm not sure if that's going to fix our problem, but I know that's something that needs to be addressed and could be part of the problem, if not the entire problem. So this one is supposed to be 47 mics, and it's showing as 11 microfarad, 10 ohms. Trash. Another 47. 13, 10. Trash. Another 47. 11 microfarad, 10 ohms. Trash. This is a one mic. Two and a half, 12 ohms. So as I say, I'm not quite sure if that's going to solve our problem, but had to be done. Well, let's just see if I can bend you around. I can't. Let me throw camera on another mount. Bear with me here. Apologize. Let's just see if we have any improvement. Well, we've got some activity. Nice eject. Wasn't doing that before. Oh, pin, baby. Okay. Well, we are making progress. I guess one of the first things I want to do is clean that laser lens. I'll do that and I'll be right back. There is another blue Phillips axial cap that's on the servo board, which attaches to the mech unit, and those are notorious, similar to the one we just replaced. But I want to try cleaning it first and see. You'd be surprised how many times that in and of itself causes good things to happen. Be right back. Well, cleaning was not the miracle we'd hoped for. Take a look at that board. So this is the servo board, and one thing I want to point out, you can see in here there's a flex cable. You have to treat that as very fragile. There's also another little cable generally on the other side that connects to the motor board. So the way I like to do it is I like to treat this side as a hinge and bring this up just gently. And the way this works, this white connector part pulls down a little bit on each side, and that frees this up. Otherwise it's locked right like that. So then hold the flex, lift it up, reveals the motor board, and there is a capacitor that I suspect will read faulty. Let's see. And the answer is 12.5 microfarads, 11.3 ohms ESR. If I was using the capacitor wizard, it would be telling me not good. And that is, in this vintage, it is a 33 microfarad. And we see that the negative side goes towards the bottom of the board. Since these are generally not visible, I have no problem marking it. Well, I've got this out. Let me just show this mechanism here. Locked, unlocked. So you can't just tug on this flex cable when it's locked, or you'll cause all kind of trouble. Don't ask me how I know. All right, I will swap that cap out, and I'll be back momentarily. Okay, capacitor was replaced. I want to point out something. This is also Bichet axial cap, and these work really nice. So if you don't have any of the blue guys and you go to buy some, consider these. They are axial. They do cost more than radial, but they just sit so nice in the space, and they seem to work pretty well in this application. Oh, I guess I hope I didn't jinx myself. This is a lucky disc, but who's superstitious? So we do have power, and mechanism seems to be working, opening and closing, spinning up, and yes, read the table, appears to be playing. Let's just see, there are about 25 tracks on here. Let's skip to somewhere in the middle and see if it plays there. Five, six, seven. Seems to be incrementing. Let's go to 25 and see if it plays there. 1, 2, 3. Seems to be incrementing. Next test will be run it through an amp and see if she's producing. But as far as we know, it's fixed. It might obviously require some cleanup, and it might require some adjustment. But generally at this stage, my recommendation is hook it up to some speakers, test it for about a day, and if it plays, don't adjust a dang thing, because, you know, there's risk with that. So I think that's it for this edition of My Tiny Bench with this beautiful 1987 Magnavox CDB560. More next time. Thanks for tuning in.